All right, welcome to your notes on eutrophication. These notes look like this. Okay, yours aren't colored. They probably just have the animals in there along with the arrows. But we're going to get started right up here at what I'm actually going to draw in some plants because this is a farm. And one of the things that we talked about are dangerous, quote unquote, with our farms is that we fertilize these plants, right? We want our plants to grow. We talked about how our fertilizers often contain nitrogen and phosphorus because those are the limiting factor of plants. So I have got my little farm here, and I actually have put some fertilizer on these so that they grow nice and tall and that I have the most successful plants I can have. We call this fertilizing. Pretty easy. Fertilized fields. And fields is always a hard word for me to spell, so I'm not sure if that's right. Fertilized fields. Get a little better view there. Beautiful. Fertilized fields. And then when I fertilize my fields, sometimes I can increase my nutrients. From land. Into rivers and streams. Okay, so I am fertilizing my land right here. Maybe I'll draw in some fertilizers. Beautiful. And those increased nutrients from the land will wash into the rivers and streams. This is one. Put a big old one right next to those. Okay, and we know, by the way, the process that actually causes runoff, we have labeled, or that causes those nutrients to wash from the land into the rivers and streams, we call that runoff. See if we can get it focused. There we go. Runoff or movement of nutrients to water. This is via extra water. Extra water in my system, so that could be like lots of rain or even lots of irrigation. So that's kind of goes along with step one there, so we're not going to relabel that or anything. This is actually a river, so you can color it in nice and blue. So now the nutrients have traveled into my river, which they're causing chaos there, but they're actually going to collect into my lake, which is the bottom part of this system right here. So again, remember we said that those nutrients that are coming from the fertilizers are nitrogen and phosphorus. Nitrogen and phosphorus. This is a P, this is an N. They are in fertilizers because they are the limiting nutrient in plant growth. So while our plants need other things to grow, like the sun and water and carbon dioxide, they also need nutrients or different elements like nitrogen, and these are actually nitrates and phosphates, but they need other elements as well, other compounds and molecules. Oftentimes what is limiting or stopping the plant growth is nitrogen and phosphorus. That's why I've used it to fertilize my field right here. But when those excess fertilizers wash into the system, they cause what we call eutrophication. So the very first thing that happens is that we get an overgrowth after they wash in. On step number 2, these are our nutrients, by the way. They've washed into our system. Number 2 is the excess or extra nutrients cause algae. I can't remember if it's EA or AE. Algae blooms. That's step number 2. Beautiful. So because the limiting resource in plants are often nitrogen and phosphorus, when I put more of those into the system, we get excess algae blooms. This is an algae bloom right here. Boop, 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 boop. And now they grow pretty much without bounds, that algae growth. So we get lots of big blooms. Remember, we showed you pictures of it in your human impacts lecture where they are just all over in the ground. So the excess blooms, or the blooms, will eventually reach their carrying capacity, or at the point at which they can grow no more naturally, and they will die. So step number 3, we put right here. Algae reaches carrying capacity and dies. Not good. Not good at all. Okay, so now we've got a bunch of dead algae in our system. What does that mean? Something has to come and break down this algae into its nutrients, or just it needs to break down. So my dead algae attracts our breaker downers, our decomposers, one of which is bacteria. So bacteria enters the system. Number 4. We'll draw a little bacteria. And actually, a lot of little bacteria enter the system. So the bacteria breaks down dead algae. That's step number 4. So that's great. The bacteria are having a feast right now on all this dead algae. Unfortunately, all that bacteria in the system is also not good, and they will use up all of the oxygen that's there. So step number 5 goes right here. Bacteria use up all dissolved oxygen. And when there's no oxygen in the system, our final step, number 6, everything dies. Get out my red pen for this because that's not good. Step number 6. Oh no, red pen, you better work. Ecosystem, or the biotic parts, dies. So we got dead fish and dead plants as a result of this, what we call eutrophication. The end result is ecosystem death. All right, we've got a few more things to write down in here though. Oh, by the way, another word for algae is phytoplankton, so let's write that down in here as well. The algae. Oh, my pink pen won't work. Frustrating. I have another one. AKA phytoplankton. Okay, aka phytoplankton grows, and that's normally a good thing. Not only can we have death via no oxygen or suffocation of all of these little friends right here, if you go over to your other one, other side of your notes right here with the little crab, these algae blooms can block out the sunlight. I've decided what color I'll use to write that down, maybe black. So let's draw ourselves a nice little arrow right here. That's a terrible arrow. The algae blooms can block sunlight, which is not good for plants. Bad for plants. Bad for plants, not good. Sorry, I wrote sideways. So that can block out the light as well. No light, bad for plants. They can't photosynthesize. Also, sediments can get caught up in this algae, and that's not good. Some of the main losses of this eutrophication are, at the very least, food, habitat, and eventually oxygen, which can lead to, or as a result, that's what that big arrow means right there, ecosystem death. Again, bad, frowny face. Okay, that's eutrophication in a whole. To review, we know that fertilizers from fields increase the nutrients from land, or the increased nutrients from land when I fertilize, wash into my rivers and streams. That happens because of runoff right here, which is the movement of nutrients to water. Runoff just in general is water running where it really shouldn't be. So this can be after a big rain event. It could be like puddles. It's moving to lower elevation. So it does what it does. It follows gravity and ends up in our rivers and streams, which will eventually end up in an aquatic, and it affects the rivers and streams as well, but it'll eventually kind of all gather wherever that river ends, whether that be the ocean or the lake, and those increased nutrients, is because this happens both in marine and freshwater systems. Those increased nitrogen and phosphorus, which are the limiting nutrients in plant growth, meaning they are what's stopping the plants from growing crazy, from growing without bounds or growing all over the place. So those enter the system, and that allows the algae to bloom uncontrollably. So think like that entire lake full of green stuff. So that's not good. The excess nutrients cause the algae to bloom. Eventually, the algae will reach its carrying capacity based on other things that aren't nitrogen and phosphorus. Most likely, it's going to run out of room. When that algae reaches its carrying capacity, it'll die. Bacteria comes in and does what bacteria does, which is break down dead organic matter, in this case the algae. But unfortunately, there's so much bacteria to break down so much of the algae that the bacteria use up all the dissolved oxygen in the system. Without oxygen, our biotic things like our plants and our fish that we're living life die, and as a result, the ecosystem will die. Some other bad things that happen, at the very least, is that algae can block the sunlight, which is bad for plants because remember, they need sunlight to do photosynthesis. Losses are food, habitat, and oxygen, and eventually ecosystem death. That is it. That is eutrophication in a nice, easy lecture. Take a picture of these notes, your notes that you've done, not these notes that I'm doing right now, and submit that to Canvas for your credit today. Have a great day.